Hi there, and welcome to this series of videos to help you with your maths revision. So, giving you time to look at a question, decide how you would start it, and then going through the answers. A daily dose of 3 questions, one pure, one stats, and one mechanics. So, let's get started. Each video will show you a question, give you some tips by focusing on the keywords and drawing out how to approach that question, and then giving the answers. So, here's today's pure question. So this is today's pure question. We've got this function that f of x is equal to this quadratic, and we're being asked to find the range of the function when that same quadratic is in the denominator for h of x. So domain and range, domain are the input values, so the x values, range is the y values. So when you're thinking about range, if you think about the graph and go up and down the y-axis and have a look to see where the graph exists. This is a functions question where we've got f of x is equal to this quadratic, and that same f of x is in the denominator for h of x. We're being asked to find the range of h of x. So when you're finding domain and range, domain are the input values, so that's all the values along the x-axis. Range are the output values, so all the values up and down the y-axis. Now, because this quadratic is in the denominator, if I think where is the minimum of the quadratic going to be, when I do 21 divided by the lowest value, that will give me the maximum that h of x will take. So finding the minimum of that quadratic is going to be a good thing to do. So if I complete the square first, and you can't complete the square with a 2 in front of the x squared, so I've taken that out as a factor just on the first 2 terms, and then we half what is in that b position and we complete the square by doing the -1. Then I will take that 2 back into the bracket, which will give me -2 here, which will add to the 9 to give me the +7. Then thinking about your transformations of graphs, because this 1 is on the inside, that's going to move the parabola for the quadratic 1 to the left, but then take it 7 up. So the minimum point for the f of x quadratic is going to be at -1, 7. So the lowest value that the parabola can take is going to be 7. So if I do 21 divided by 7, that is going to tell me the maximum value that h of x can take is going to be 3. So I now know that h of x has got to be less than or equal to 3. Then looking back at the completed square form, you can see that whatever value of x is, because it's inside the bracket and we're going to square it, that's going to be positive. Doubling it on the front, it's still going to be positive, and then adding 7 more, it's going to be even more positive. So I can see that this graph is always going to be above the x-axis. So putting those two ideas together, we're going to have that 0 is less than h of x, which is less than or equal to 3. This question is about sampling, and in particular stratified sampling. So stratified sampling is a type of random sampling. All the random sampling techniques involve you needing to have the sampling frame, which is a list of the entire population. So if you were doing a stratified sample of a school, you would have everybody's name on the registers, and that would be your sampling frame. So without having the sampling frame, then your sample cannot be random. This question is about sampling, and there are two ways we can take a sample. We can do a random sample or a non-random sample. So when we have the entire population, it's random because we randomly generate data from the entire population, and unless you've got the entire population to start with, then it can't be random. So there's three different types of random sampling. There's simple sampling, which is just names in the hat. Systematic is when you randomly generate where you're going to start within your population, and say my population was 100 people and I wanted a sample size of 20. If you do 100 divided by 20, which is 5, and then randomly generate where you're going to start, and from that starting point take every fifth person until you've gone through all the population, and then you will have a sample size of 20. The other random sampling type is stratified sample, which is what this question is about, where you have to proportionally represent each of the strata, each of the groups within the population are proportionally represented in your sample. Non-random sampling is a quota sample or an opportunity sample. A quota sample, you haven't got the sampling frame, but you have decided that you want to have 5 people between 18 and 20 and maybe 10 people between 20 and 25. You decide on those numbers, and then an opportunity sample is you taking the opportunity. Maybe the market researcher is standing outside a shop and taking the opportunity at 9 o'clock in the morning to fill the quota of whatever they want their sample size to be. But this is about stratified samples. So we're told that there's 84 students in year 12, 56 in year 13, so altogether there's 140. So 84 out of 140 are in year 12, so we want that fraction of the 40, which is our sample size, to be from year 12, and that will be 24 year 12 pupils. And then in year 13 there's 56 out of the 140, so we want that fraction of the sample size 40, which means we're going to have 16 pupils from year 13. This is a moments question. We've got a uniform beam. So uniform means that the weight is going to be acting at the center and it's in equilibrium. So that means the resultant moments is 0 and the resultant force is 0. So putting all our forces on the diagram, we've got the 12G acting down in the center because we're told it's uniform. We have the beam in equilibrium, so we can do forces up equals forces down with the 2 reaction forces at the pivot, but that's given us 2 unknowns and we're being asked to find the reaction at C. So if we take moments about A, so when you take moments, it's the size of the force times the distance away from where you're taking the moment. So we're taking at A, what forces will affect the turning? Well, the reaction at A, because that force is being applied at A, that's not going to affect the turning of the beam. What will affect it is the 12G, that will be trying to pull it down, but that will be equal and opposite by the reaction force at C. So if you just do 1.5, the distance to the 12G times the size of it is equal to the 2, because the whole beam is 3, so the distance from A to C is going to be 2 times the reaction force, and just solve for the reaction at C. So 1.5 times 12, and then we need to divide by the 2. It's going to be that 9G is equal to the reaction at C. So the reaction at C, you can leave it as 9G, or you can do 9 times 9.8. It's going to be 88.2 newtons. Thank you so much for watching. Hopefully this has helped you with your revision. If you have any comments that you want to leave or any particular questions you want me to focus on in any of the 3 strands, the pure, the stats or the mechanics, please do leave any questions. Please do like and subscribe, share it with your friends, do all that good stuff. I would really appreciate it, and I will see you on the next one.